All right, can everybody get a call out to see who's online?
Ironclad is here. We're watching and waiting in breathless anticipation.
How many students are there?
9.
Okay. And the other teams?
We have 4. We had a few that were called off to work, so we're down a few.
Okay.
And I think Tony's microphone is all messed up. We're getting a lot of feedback from it, so he is responding in chat. And we want to see a picture of Drake wearing a tuxedo. So.
You want to see a picture of what?
Drake wearing the tuxedo.
I don't know. How do I share my webcam with you? He's there we go.
Oh.
Yeah, we're very formal here down in Bradley. Everybody's dressed up the same way. We just can't show them.
All right, just want to start with just general discussion. How far has everybody gotten on the videos? Did everybody get the simulator to work?
Drake?
We got through the state machines, and then we played with the simulator a little bit as well.
Okay. John and your team?
I keep having connection issues.
Most of them have watched the state machines and the introductory LabVIEW videos. I don't think we've gotten to the simulator.
Okay. You just haven't got to it, or you weren't able to get it to work?
Haven't gotten to it.
Haven't got to it. Okay.
My revolving remote.
All right, so let's do then a kind of a quick review of the simulator.
I think they're recording.
Any Ironclad or PorterBots, any questions or confusions that have come up in the videos and trying to implement it that you need clarification on, or would like me to go over and make sure I cover anything that you're struggling with?
Go ahead.
We're not struggling with any specific concepts in general. I think if anything, I guess it would be helpful to get like a bit more in-depth stuff on the simulator, because we really just got it opened and like moving around the thing, but utilizing it more than that, not so much.
Okay, cool. Good, because that's kind of what I've been working on the last few days, is just stepping through adding different components to the simulator. To the ball shooter is that the one you guys been working on, or the other one?
We just got it to drive around the virtual robot.
The ball shooter one?
I think it was the one with Recycle Rush, because we have an old version of LabVIEW on a lot of our desktops in the computer lab.
Okay. All right, so last year's they have a ball shooter, so that's the one I've been working on, but the same concepts will apply. Okay.
If you guys need to be jotting some notes down as you're going, please do. They're recording this, but notes for yourself. And I am correct in understanding that this is being recorded, right? So that we can look at it later if we need to?
Correct.
Okay.
All right, and eventually we'll have. Did the Google Drive thing get all set up? I haven't tried to do that, but so I'm building the different stages that I'm going through, kind of one at a time. So you can start wherever you want, or you can kind of look through each one and see kind of how I'm stepping through. So the first thing, this is the ball simulator after you go through and just kind of an initial startup of it. And so I'm going to open the project.
So, Mark, are you saying that this is a project that you are able to share with us, or is it something that should already be built into LabVIEW?
Each of those folders are, it's the ball simulator, the 0 item. Let me open this back up. So this is the start. So after you've asked it to build you a ball simulator project, that's the first one. And then I took that and copied it, and then I went in and added some of my template stuff and added the joystick stuff in this demo project.
Okay.
And then I took and copied that. Does that answer your question?
It might have, and actually it may have brought up a different question, which is maybe we should pretend that we don't even know how you opened up the initial ball shooter.
Okay,
Since
that's
we're
good.
running on an old code right now, so I'm not sure that the kids maybe exactly know where you were at. Sorry about that.
So this was last year's 2018 kind of startup splash screen.
Okay.
And we say we want a new FRC RoboRio project. And then I click on that. And then it brings up this dialog box. You put in your team number.
Are you guys all doing this?
And then you would select, it gives you, last year gave you 4 selections. There was a command and control architecture. You can learn LabVIEW with this Mechana maze simulator, and you can learn LabVIEW with this ball shooter simulator. And then you just click finish. And oops. First you want to decide where you want your project to be. The default will put it in your documents, your LabVIEW data documents. But you can change that location, and you can give it a different name if you want. And then you just click finish, and
okay. Can we pause for just a second there? Okay, so maybe
go ahead. It's building it right now.
Okay. Maybe you guys can partner up if you got old ones and new ones and work on a new one. So would it be accurate to say that this is just building a basic robot simulator and it's giving us all of the default code that FRC always gives us LabVIEW coders?
Yes, it's building a specific simulator project.
Okay.
So this project cannot run on the RoboRio because they put all the code up here in the My Computer target.
Okay.
The robot main is in My Computer. In a normal RoboRio project, the robot main would be down here in the Rio target, in the
Gotcha.
RoboRio target. Okay? So it is specifically designed to run in the simulator, to work in the simulator. You don't have to do anything extra to make it run in the simulator except install the LabVIEW simulator program needs to already be installed.
Okay.
Okay? Did that answer your question? Did more questions come from that?
Not yet. This is good. I think we're good.
All right. So to get the simulator to work, we need to open the driver station and give permission for the driver station to open. You need to make sure you set up the driver station with your team number. You can have the dashboard open or not. It may or may not work. Usually it doesn't. because you have to intentionally program the dashboard. And I didn't want to cover that today. We'll do that later another time. Make sure your joystick is plugged into your USB port, and we can check here. If we click on the USB tab, we have a game controller plugged in, and as I move the axes and press the buttons, you'll see that my driver station does see my joystick. Okay, so we have the driver station open. Now we can run robot main. So we open robot main. And then if we hit the run button, it will open the simulator. You guys see that?
Yeah, we're rapidly deploying our joysticks. Well, the first comment I heard was, "Oh, that's so cute." So I guess that's something. Something must be showing on somebody's screen.
And then you can kind of zoom in. That's what the ball shooter looks like. If we go back to the project, there's this robot simulator README file. We can open that up, and that tells us what all the different parts on that robot are connected to the different parts of the robo reel. So the left and the right motor for driving are connected to PWM0 and PWM1. The shooter, left and right shooter motors, PWM2 and 3, and so on. And then sensors are connected here. So our gyro is connected to analog input 1. Our ultrasonics are on here as well, connected to DI1 and DIO2. So if you're wondering, when you go to add certain actuators or whatever, this documentation helps you figure out what those things are.
Okay.
Okay. So there's our shooter. Now if we go back to our driver station, just like any robot, you have to enable, get it to work. So now my robot's enabled, and now I'll push the joystick forward, and you see it drive forward, drive backward, and then my A button, green button, will shoot a ball. Press the A button, and it shoots a ball. Okay, any questions on that?
Evan, do you want to check? Does it matter which joystick is? Is it aux or is it the driver? Or... Joanna, yours work? Preston, Xavier, good? Okay. Okay, we got 3 virtual robots all moving and shooting virtual balls.
Okay, so some things to note is you can change some colors here. If you turn on the follower, everywhere the robot goes, the camera will follow the robot, and you can zoom in or out. I mean, really in. And if you want to view it like you were if you were the driver, you can hit this driver button, and it will give you the driver's point of view. But you have to have the follow zoom off. Well, I guess you can turn that on too now. Okay. So you can have 2 perspective, the side perspective or driver perspective, and you can have follow on or off. Okay. So if we open the code, they've also created some scorekeeping and stuff here on the main front panel. Allow you to, if you shoot balls, it'll score for you. So if I go to the side view here, and I shut off, you can also manipulate and scroll around. So you see back here is a big lattice, and what happens when you shoot a ball through, eventually it'll dump back out into through this little tiny hole in the bottom. It'll eventually go through all these ramps, and it'll come down to the bottom, and it'll come back into the playing field. So ideally, for this one, if we could play around with it and get all of these different actuators to work. So you see you have a ball intake wheel that you can turn on. You have ball shooter wheels. Inside of here, there's a servo that opens and closes and lets the ball through. And I think there's also an agitator. You see the agitator agitating the balls to get them to get into the feeder. I think.
You guys open to that?
Okay, so there's lots of wheels and shooters. I don't even know what that is. Oh, that's the other wheel. Okay. So you have a drive to program. You have an intake to program, a shooter to program, and some servos in here to manipulate and control the ball. And then we have two sensors. We have a gyro sensor that will track our rotation, and we have a distance sensor that will track the distance anything is in front of the robot. So it gives us a good starting point to figure, to play with programming robots without needing any hardware to learn how to program the robots.
Just for a little side question, I don't want to derail things much, but is it hard to build one of these virtual things? In other words, if we decided on January 7th that, hey, we know we want to have an intake and a shooter and a gyro on it, can we build it virtually and start testing out autocode, or is that a lot harder?
They may make it easier next year, but right now it's more this is what they give you.
Okay.
And one of my coworkers actually got into it, and he tried really hard to try and make something or try and figure out how all this worked. He had a little bit of a handle on it, but there's a whole bunch of physics. There's a whole bunch of physics engine stuff in here to figure out, and planes, and there's some program you can use to do that. But for most people, the answer is no. Just you have to take what they give you.
That sounds like a good answer. Okay, cool.
All right. Okay, so that's what you get with the starting of it, and then I want to talk about taking the videos, and giving you. I back up a little bit here. So this is what they give you for the starting. If you go to begin, they create all these openings.
Do you want the kids to open up the begin right now or not?
No, I guess just follow along.
Okay.
So they're not looking up, down, right? This is what they give you. They start in the begin, and this is how they initialize all the hardware. I'm gonna try and teach you a different method than this, because I think this, and then if we go to teleop, there's kind of more code in here where we read things off and drive things, and then if you go to time task, there's also code in here. And the more complicated your application, the more this becomes spaghetti code and harder to read. Right? You can see that all we do is we have a driving ball shooter and we shoot, right? And this is already how complicated the code is. And so if we wanted to make an add some automated functions to the drive that set to rotations and go to distances and add other functions or whatever, you can see this code just becoming really complicated and confusing and coupled all together.
I can see that.
And there's no structure in here anywhere for state machines or driving state machines or creating a state machine. So I'd like to show you kind of the architecture I've been working on that helps give you a format to be able to keep expanding your code and keeping it readable and keeping everybody kind of on the same page. Because the way they do this, there really doesn't seem to be a rules of when you put stuff in teleop and when you put stuff down here in time task. And I could argue with whoever wrote this, why did you put the drive up here in teleop and you put no drive code in time task? It doesn't make, I would argue, why would you do that? So I want to, with this architecture, I want to like establish some rules among programmers so that you all kind of agree on the same rules. So one person can go and program this subsystem A and another person can go and program subsystem B. They have to make a few agreements about how they transfer data between each other. But then eventually that person can take their code and plop it into the main. The other person with subsystem B can plop their code in the main, and we won't have all this. One person won't be working on the entire code base. You can have multiple people working on the code base. In this situation, it's not the case. If somebody wanted to change the servo, they'd have to take the entire project themselves, take it over. Nobody else could be working on it because they would create conflicts and stuff.
Sorry.
All right, so don't save. So I'm going to open up the demo 3. I'm going to keep building demos and then keep adding them to the list as I add features and stuff to this ball shooter, and allow you to kind of look and kind of get an idea of kind of the direction that we're going. So this is the ball shooter application, and I've added drive and gyro and distance sensor, and I've also started to add some tracking to be able to rotate to a specific angle using the gyro. All right, so I'm going to open robot main. And this should look similar. But if we open begin, you'll notice I don't have hardly any code in begin. And that's because all the subsystems, I try to keep them all self-contained. So all my subsystems are going to be in time tasks, and they're each going to be in their own separate VI loop. So you can see I have 3 sensor loops. I have the game controller loop, I have the gyro loop, and I have a distance sensing loop. And then I have one actuator set up right now, which is just the drive itself. All right, so if we open the game controller loop, the sensor loops are pretty simple. This is all the data that the sensor loops, that the game controller loop looks at. And then I try to kind of explain what you want to do in each section. So as this is where we create a cluster and we bundle all the data that we're going to use, this loop is going to use in the cluster. And then in this while loop, we read the data that we need, the current data. So in this case, I'm reading the current time. I'm saving the previous time. I'm reading on the front panel the target time that I want in milliseconds to run, and I'm reading the robot mode. And then in this section, I'm doing calculations. So I'm calculating the cycle time, how fast this loop is running. And then I'm reading the reference for game controller 0 and game controller 1. So, sorry, going back here, this is where I initiate the 2 joysticks for the first joystick and the second joystick, and I save the references in the cluster. And then if my robot mode says that I'm in teleop enabled, I start reading the joystick values here. I read the axes, the buttons, and the point of views from my joystick, and I store them back in the cluster. So in this section, I am actually doing the sensor work. I'm reading the sensor data, putting it back in the cluster, and then in this section, I'm transmitting the data to my global variables outside, so other things out in the world can read my game controller information.
So this VI would basically be the same year after year, wouldn't it? More or
Yes,
less?
it's the same. If you use the same controllers, yes.
That's cool.
And then, you see it's because it's one VI. And it's in this thing called a library, which means all the VIs that I need to run this game controller loop are all in this library, and I can move this library around, bring it into this into any program. So any questions on that yet? Any confusions? Okay, so I'm putting all my. I'm sorry, that was quick. Did anybody have any questions?
Okay, I guess I do. Is this
okay?
Is this the sort of VI that we should make ourselves the first time, or should we just steal yours?
Great question. So, great question. So, in the project, I have a folder called Systems, and these are all the systems, the subsystems that are being created, okay? But I've also created for you guys templates. So there's an actuator template library, which there's a little more involved in an actuator making things run than there is in the sensor. And here's a sensor template here, okay? So if you were wanting to make a new sensor or activate a new sensor, you would come up here to the template sensor library, and you would do a save as, and you would give it a new name. What's another sensor we could do? Encoder maybe. And then we would go to our systems folder, create a new folder called an encoder. And
so this is in the ball shooter simulation inside the RoboRio folder. Is that where I saw you putting it?
Yeah,
it's inside my computer, so it's part of the simulator. Okay. Come on, be honest. Wow.
Save it to, I'm supposed to save it to Ball Shooter 3. Yeah, I put it in the wrong spot, so anyways, I'll keep. So there's three. I've created 3 templates. One is for a sensor that you would like to add. One would be any new actuators that you want to add, and then one would be for more of an autonomous loop that's more all software. It's not interacting with the hardware. It's commanding other loops to do things. So in autonomous, you would create an autonomous loop. It would have states and go through a state machine, but its actions or its commands would send command data to the drive or to the ball shooter and tell it when to do those things. So there's a template will be a template for that as well.
Okay.
Right. So in a sensor library is the sensor loop itself, and that's kind of what I was showing you here. It's a loop, and it has three. You just put code in these three sections. Here we get data coming in. Here we do processing and reading the sensor, and then here we send the data out. And then when the loop stops, we close our references. That one's pretty simple.
Yeah.
In an actuator one, we have a little more things that we need to be concerned with. So this is the drive loop. It's this loop down here. Get it open. Again, we have all the data that we need. If we want to add items to this cluster, say we want to put a Boolean in here, and we right-click and give it a label. And then we can pull down and just add a new item to that cluster. And then anywhere in the code, we can do an unbundle by name and read that value. Or we can write to that value using a bundle by name.
Just so you're aware, we are having a frame rate problem, so your cursor's jumping 6 or 7 inches every second or so. So it's
so you're getting about one or two.
We're keeping up okay, but it does jump around a bit on our screen.
Okay, thank you.
I think we're all good, right? Okay.
So that's how we would add items to the cluster.
That's cool.
Anytime you want to add a new item, and you want to try to keep all the data that you unbundle and bundle in your loop, you want to have it here declared, so it's easy to kind of scan quickly to see what data this loop cares about.
And that's always on the front panel too, right? So you can always look at it and see what's going on. That's cool. Is that how we do it?
So okay, here's our sections. We bring all the data. We bring all the data into the loop that we want to read. So there's a global variable here called command drive. So the commander, or the thing that's commanding the drive, which is either teleop or autonomous, it fills in this cluster. So it selects a mode. So I can set stop mode. I can say manual control mode, and then it fills in this data here to be able to run the drive.
Would we be correct in understanding that those are different states?
These are, yeah, the loop itself will have different states.
Okay.
But it also will have a command mode.
Okay.
So whatever's commanding this drive to do. So in teleop, you will take buttons from your joystick controller. I'll show you that in a minute. And you will set these values based on what your joystick buttons are, or your controller buttons are set. And the drive will read this cluster, and it will set its state and its output to the drive based on what these values tell it to do. So everything you want the drive to be able to do, you need to be able to say with this cluster.
Okay.
All right, so that's one of the things we're reading in from the command. Whoever's in command, we read this cluster to tell us what to do. There's a gyro also running in a separate loop in this loop over here. And it's creating the gyro angle, and we're also going to read that in to our drive because we need it to do targeting calculations to tell us to get to a certain angle. And then there's a little gain for when we do calculations for PID calculation. And as I evolve this code, I may take these things in and out of my cluster, depending if I need them or don't need them anymore. If I decide I don't want to do rotation tracking anymore, I can remove stuff or add stuff. All right, so then the next section here is any calculations that you're continuously repeating. So one thing I like to have in here all the time is to calculate my cycle time. How fast is this loop running? So that'd be a calculation that you do all the time. You're always checking to see if the stop button is pressed or the stop command, the global stop command is true. If the global stop command is true, we're going to stop the loop and we're going to call the shutdown state. Otherwise, we're going to just pass the state through. But any other calculations that you have to do all the time, like you may have to constantly do speed calculations or something like that, that are not state dependent. And then this next section is your state. So we look to see what our current state is, and then we do the state logic. And like the videos show, we generate the next state. Every state has to generate the next state and an action list. And that action list can be blank, or you can actually do no action as well, but you have to create something here for this wire. So you'll see I have a case for every state. So for instance, in the stop state, I say come back. I look at my commands. You can see I'm unbundling my command from my command cluster. And based on that, I am setting the state, the next state that I want to do. So if my command is telling me to stop, I set the next state as stop, and I call the action stop. If my command is go to angle, I still say stop, call the stop state, which I shouldn't do. I should. So that's a bug. I say go to angle. I should say go to angle state, but I still want the stop action. And then the next time around, the state will be to angle, and I will do whatever to angle tells me to do. So you can see in this instance, I'm very dependent on my drive command to set the state, but they are different.
You guys still good with that, or do you want any clarification? Evan, you're looking a little fuzzy.
I'm confused. Or not. It's hard for me to form a question.
Okay.
I can't give a question, but I just don't understand.
Okay, so that's all right. Can the other people in here help clarify when we're ready to dismantle this better? Okay, all right. Okay, I'm sorry. I was just doing a check-in with my kids.
Yep. How's it going?
They range from I would say 20% understanding to 95% understanding. So we've got a good enough range there that I think they can help each other untangle whatever they need to. So I would say let's keep going towards whatever our challenge task is, or our goal for accomplishment.
Okay, and then this section we're doing each of our actions. So we are setting, most of the actions are going to set some kind of hardware, the actual hardware X and Y of our arcade drive over here. So in stop, we're just going to set 0 to both, so it doesn't turn, it doesn't move forward. In manual mode, we're going to read the X and Y that comes from the command manual and write that to the hardware. And then, each action is going to specifically do something that will set the hardware values. And then in the last section, we are writing all our global variables, and we are physically writing to the drive VI that will set motor values. Okay, so we have stop and manual. So how does this, how do we take the game controllers and tell our drive what to do in teleop? So I'm going to go back to the robot main, and I'm going to open teleop and kind of close this loop. So we read, remember our game controller is running in its loop and it's constantly reading the game controllers, and it's putting the access values and the buttons in a global variable, right? So I'm reading the access array, and I've created this enum that represents the accesses on my controller, so that it will unbundle or will index the correct item. And then I have my buttons. I'm doing the same thing, looking at the buttons. And then I also have an enum for all my buttons. So I don't have to remember the number, what number yellow button is for. My enum tells me that. So when I push the yellow button, this case will go true. I will set my mode to go to angle, and I will set my angle target at 180. So I'm hoping that that command cluster, there's my command cluster for the drive. My drive will look at the go to angle command and the angle target and try and rotate to 180 degrees.
So you're not actually telling it to rotate 180 degrees. You're telling the gyroscope to rotate. If it was already at 150 degrees, it would rotate another 30 to get to the 180?
Correct.
Okay.
I'm telling it rotate until the gyro reads 180 degrees.
Got it.
But it's dependent on how you program it.
Right.
Right. That is how my program works. If both buttons are false, I tell it to go into manual control, and I feed it the X and the Y values from the accesses.
Let's look.
So why this is powerful and why we're kind of doing this is because what I see is a lot of people use joystick code, and they put the joystick code directly to the motor drives, and they write all this code in teleop, and then when it comes to autonomous, they kind of got to start over, right?
Yeah.
Because they've intermixed the joystick code in the drive code all together. But when you get to autonomous, you don't have joysticks anymore, right? So what this command cluster allows is that all autonomous has to do is fill in this cluster, and the drive will respond, not caring if it was a human in teleop mode trying to run the drive or an autonomous in autonomous mode trying to run the drive.
You guys don't understand that? So it's putting a buffer layer between where the commands came from and what the commands are doing.
Correct.
Okay.
Very well stated.
Cool. I like it.
Okay. So, running low on time here. This is where I would like to kind of encourage you maybe direction to go. One other thing that I need to re-clarify is I'm going to open one of these global variables. So one thing in using global variables, we want to ensure it's important that we have one writer and multiple readers. I think I covered this in my videos. But the global variables need to be named by who is responsible for writing this data. Okay, and then I've put these big yellow signs in all the global variables explaining how you name a global variable. So for instance, let's open something different. I'm going to open some of the drive global variables. So this is also a actuator library. So we have a drive library. Inside here are all the type defs that this library depends on. And then we have two global variables. We have a command global variable. So this is something the commanders use, teleop or autonomous, to tell the drive what to do. And this is the global variables that the drive generates so other people can read and look. So if I open the drive variable, you'll see that each one, there's instructions here on how you need to name the variable, so that when you see it in the code, you know who the writer is. So this variable is labeled drive state machine. That means he is the writer. Drive state machine is the writer. Nobody else is allowed to write to that except the drive state machine. And then the description write motor set. And so you'll see every global variable, you should be able to identify who the writer is. And if you see something like this, oops, and you see somebody writing to, change to write, so you see somebody writing to a variable like that, and this name does not match this location, then they're breaking the rules. And the reason we do that is so that we avoid race conditions. Having multiple writers to the same data type can create race conditions, which are hard to find, and I would like to keep people from having to bear that burden.
and maybe save yourself from having to look for it in our code, right?
Well, I know how to find it quickly.
Okay. So the naming convention is the library name that's writing the data should be the first thing that we see, right? Library name?
Library name for actuator. It might be, each one has a little bit different flavor to it, but yeah, the library name. So in this instance, it's drive, and then the loop, state machine. And then
SM,
state machine, sensor, or actuator.
Sensor, actuator. Gotcha. All right.
And then the data name that describes what this data does.
Okay.
So my challenge for the beginners is to get the ball shooter simulator working, play with it, and then go into the code and see if you can understand it, the beginning ball shooter. If you can just understand when you push the green button, why the green button shoots a ball. And when you push forward on the joystick, why the motors turn and drive forward. That would be for beginners.
Now, is this your new improved code? I mean, we'll have to get.
I would say for beginners to just get to that far, at the very beginning ball shooter code.
Now, but I'm asking, is that ball shooter code? Is that your code that's been new and improved, or is it the original LabVIEW provided stuff?
The original for the beginners.
Okay.
And then
gotcha.
for the intermediate and advanced, if you can start comparing the initial code that LabVIEW gives you to kind of the direction, the state machine directions that I'd like to move us into, and try and understand that, and try and open the demos that I'm going to provide on the Google Drive, and see if you can kind of understand the steps that you're taking. And then for the advanced, I would challenge you with trying to add the different actuators to shoot the ball. They haven't got that far yet.
Okay. This seems like plenty for us to keep our brains occupied with. Plus, I think I dropped the ball. I think I was supposed to share a Google Drive with everybody, and I don't think I finished doing that. But I will do that perhaps this evening if I don't also fall asleep.
And then the other thing is our team uses a program called Slack. Has anybody heard of that program?
Yep.
It works on computers and phones and stuff, and it's a communication like message board kind of application. And it'd be a good way that we could all communicate, ask questions, and
we have heard of it. We tested it and decided to go a different direction for our team. But
okay.
I might have the controls kids see about joining up with it, and it'll be a good beta test to see whether that's something we want to move to all team in the future.
What software do you guys use for communication?
Well, we use Team App, which is just a app on phones and whatnot. Okay, sorry. But we can try out Slack. It's not a problem.
Okay. Well, I can try out Team App too. I don't have a problem doing that. If the other teams are able have a preference or whatever, just a way that all three teams can ask questions and then answer each other's questions, or just so I get a sense of what people are struggling with and what they need help with, or where there's some confusion. If I created a watch me video where I go through the different steps of the demos and show how to copy a library and how to add things to the LabVIEW code, do you think that would be helpful?
Can you repeat that one more time?
If I created like a step-by-step video, opening the template, copying one of the libraries, and showing how I got from no gyro loop to a working gyro loop, so people could follow step by steps. Do you think that would be helpful? And I put that up on the drive.
Yes.
Something you could kind of watch and then go and do yourself.
I'm getting enthusiastic head nods.
Okay.
And I think it might not even be bad to just put that on YouTube instead of just. I mean, we can do it both, but
okay.
Because honestly, I'm very much a novice with LabVIEW. I haven't dug into it anywhere near as much as these young people have, but I understood insanely easily everything that you were working on with putting stuff into a wire flow and pulling it back out again, and that made way more sense than that spaghetti code that I saw at the beginning. So
okay.
Yeah, I think we've got kids that have to get to a band concert and their rides are here, so we're going to have to start backing up. But I will get that LabVIEW or the Google Drive shared with everybody, and we'll start getting some slackers going on Slack and see where we can go from next steps then.
Excellent. All right, thanks everybody, and I guess we'll.
Anything else from the PorterBots or the other side?
No, so we're waiting for you to get the Google Drive up so Mark can post this code sample there.
Yeah.
Okay.
Yes.
Okay, and then I will get the video rendered and posted to our YouTube channel as soon as I can.
Oh, awesome. And if I make videos, you can put those up on the YouTube channel as well?
Absolutely.
And how do I get those to you? Can I put them on the Google Drive and you?
Yeah, I would say
Yeah,
post them to Google Drive as the intermediary, and then I'll grab them from there.
Okay, excellent. Cool.
All right. Well, thank you very much. We appreciate your time. This was informative.
All good
Right.
up there at Schur's? Tony's been quiet out there.
Say again?
Tony's been quiet out there. I'm just checking to make sure Schur's is still with us.
Did he get his mic working? Okay.
All right. Well, thank you very much.
Yep, and I'll start working on videos.
All right. Have a nice evening, guys, and a Merry Christmas if I don't talk to you.
You too.
All right, Merry Christmas, everybody.
Thanks, Mark and Tony.